Good morning, everyone. I just wanted to kind of give you an update. I've been reviewing the 25 responses that I've gotten so far on my Google Forms, and I've started to notice just a couple of issues. Some of them are just basic. One of them is on me, and I just wanted to make sure that you guys are able to see this. So go ahead and look at it. I did problems 2, 3, 4, and 8 here, and I just wanted you guys to take a look. If you guys have any questions still after this, go ahead and send me an email with a screenshot of your work or a picture of your work. So the first one is a little difficult because you guys aren't used to this. Just the way it says, express the length of AB using sine or cosine. So if we're looking at this angle right here, we know this is our opposite. We know this is our adjacent. And we know this is our hypotenuse. Okay, so which one is length AB? Well, that's a good question. Length AB is going to be this length, which is our adjacent. So are we going to use sine or cosine if we have our adjacent? I'm going to have to use cosine. So cosine of theta is equal to adjacent over hypotenuse. And with this, what we're going to have to do is just plug in what we know. So we know cosine of theta, our adjacent, is AB, which is the weird part for you guys because we haven't done this for, 5 weeks? And then our hypotenuse is going to be 1. So AB divided by 1 is AB. So I had about half you guys get this and about half you guys get it wrong. And I just wanted to address it because you guys aren't used to this notation. One of the problems was bad to write on forms, which I believe is the next one. So here's our triangle in this given problem. And the thing is, it wants us to find sine and cosine, but we don't know our hypotenuse. So we're using this angle A. This is our opposite. This is our adjacent. And this is our hypotenuse, which we don't know. Okay. So what we have to do is we have to find the hypotenuse first. So if it's a right triangle, we know we can use the Pythagorean theorem. So we're going to have 6 squared plus 2 squared equals c squared, which is 36 plus 4 equals c squared. And when we do this, we're going to have to take the square root of each side. And we're going to get that this is going to be equal to the square root of 40. Okay. We can reduce it, but once again, Algebra 2, you just have to get to this part. When you get to pre-cal, you're going to be expected to go through and reduce, so I'm just going to leave it for sake of time. Now, some of you took the actual square root and gave you about 6, right? It's about 6. That's what people were writing. So I had some students plug in 6 for it, which is completely fine as long as you guys are stating that you're approximating it to 6. So we know that. When you're finding cosine, we know cosine of A is adjacent over hypotenuse, so we're going to get 6 over root 40. And you can't have a root in the denominator, so you're going to multiply by root 40 over root 40, and you're going to get 6 root 40 over 40. Okay. Then we're able to reduce this, and we cross out a 2 in each of these, so we're going to get 3 square roots of 40 over 20. And that would be your answer for cosine. I can see why many people approximated and plugged it in. If you gave me a decimal answer, that's completely fine as of this point. I'm just doing that because I don't have a calculator in front of me. With this, sine of A is going to be opposite over hypotenuse, so 2 over 6, or 2 over square root of 40. And we go through the same process. Okay, and then tangent of A is opposite over adjacent, which is 2 over 6, which will give us 1/3. So tangent's real nice and easy. The other two are pretty gross. And that's why I said this problem was my fault. It came out nasty, and it's hard to type that into forms. I should still expect you guys to be able to do this. Maybe not putting it into this form, but you should be able to get to here. Okay? That's kind of my expectation. This problem, I don't know if it was worded the perfect way. The thing about it is you guys need to know that sine is your y value and cosine is your x value. So it's asking on this unit circle, if you read it, it says draw a unit circle, then determine which of the following radian measures satisfies this. And then you guys have to look at all the answers and select all that apply. Okay, with that, we know that we're going to be going where y is negative, so it's going to be down here below, and where x is positive. So this means x is positive. This means y is negative. So that means, once again, if we go around, this is positive, positive, this is negative, positive, this is negative, negative, and we know this is positive, negative. So it's going to be somewhere in this quadrant. So you're going to pick whatever radian measure is in that quadrant. I'd like to remind you this is 0, pi over 2, pi, 3 pi over 2, and 2 pi. So anything between 3 pi over 2 and 2 pi would be your answer. It'd be in this quadrant here. Okay. Now, the last one, this is one that I was a little surprised about. I went through a problem that was very similar to it. The issue is I had triangles drawn for my problems, and this one I didn't draw a triangle for you. I probably should have, and I'm sorry about that in case you guys were on this for a while. So with this, what's going to happen is we're going to have our triangle. Okay, we're going to label this theta. It doesn't really matter. And what we know, it's in quadrant 2. Maybe I should go back through this and make this a little nicer and easier in quadrant 2. So if we do this, we're going to be in quadrant 2, and this is going to be our triangle right here. Okay, and we know this is theta. So what it's asking is it's asking us to find the different values. In the unit circle, what do we know our radius is? It's always going to be 1. Okay, our cosine, this is your x value, which is negative 0.5. So essentially what we have to do is find our y value. Okay, we have to find our y value, what's that equal to, and then we're able to find sine and tangent. Remember, your x, y coordinate for this point is going to be your cosine and then your sine. Okay, and tangent you get by dividing the two. So when we do this, we're just going to plug it into the Pythagorean identity. And that states that we have cosine squared theta plus sine squared theta equals 1. So cosine is 0.05. Negative, no, I messed up on that point there. It's actually going to be 0.5. Negative 0.5. Maybe I should erase all of that. I'm sorry, guys. 0.5. And that's going to be squared plus sine squared equals 1. And 0.5 times 0.5 is 0.25. Plus sine squared equals 0. Or equals 1. So we're going to subtract 0.25 from each side. And we're going to get sine squared theta equals 0.75. Okay? And then from this, all we have to do is take the square root of each side. And we're going to get sine squared theta, or not sine squared, sine of theta equals, and then we just have to take the square root of 0.75. So the square root of 0.75, let me take that square root. Square root 0.75 is going to give us 0.866. 0.866. And it's going to give us positive or negative. And if you guys recall, we're supposed to determine what the sign is here. And we know that our x value is negative, and we know our y value is positive. So it's just going to be the positive value for this. So we found what sine is. It's 0.866. And what we need to do is find our tangent. Tangent of theta is equal to, once again, sine over cosine. So we're going to take 0.866 and divide it by our cosine, which is negative 0.5. And when we do this, just give me one moment, 0.866 divided by 0.5 is going to give us 1.732. So 1 point, and it's supposed to be negative. It's negative 1.732. And that would be your answer for tangent. Okay. Thank you guys very much. If you have any questions, please send them.